Hello again, this is Gary, and we're going to continue our series called Digesting Drawings. And today we're going to talk about DC elementary for a disconnect. You may know it as a MOD, motor operated disconnect, or MOAB, motor operated air brake. So we're going to start looking at this drawing, try to digest it. First thing, like you do in any drawings, make sure the seal, PE stamp's there, the name, the drawing number, the revision number is in alignment with the revision number stated over here, which is 00, and the date. You want to look at the date as well. And then you can compare that against the transmittal. Look down here at reference drawings. It'll help you understand the circuit and look at the legend. And also pay attention to the notes. Okay, so the note section is here. So the first circuit we're going to look at is right here. It's a 125 volt DC circuit. So right away, I know this is going to come from a DC distribution panel, which I'll have to prove from. This is a circuit breaker. This little indication right here lets you know that this breaker, this circuit right here, DCB2 circuit 49, feeds this motor operator and also feeds another one, something else. We have to go to this drawing and figure that out. First thing you'll see, and this is typical on these MODs, it's under voltage relay. It's basically an alarm. So what you can see, this is a positive rail, and this is a negative rail, which we've already talked about. So when the circuit is energized and the breaker's closed, you're going to have positive DC going through this under voltage relay, which will energize it. So this alarm contact will remain energized in the closed position, and when the power goes away, the under voltage relay de-energizes, opens the contact, and sends an alarm. It's basically how it works. So that's one of the things I look for is an under voltage relay, a way to alarm the system if you have a catastrophic failure, which in this case would be no power. Then you can't operate the switch. And moving along, this is the main motor circuit. So in this particular application, this motor runs on DC power. Sometimes you have AC power, but for this application, it's DC power. This is the stop button. This button right here and all this circuitry is located outside in the MOD control cabinet. When you hit stop, it kills power to this entire circuit. So regardless of what position the rotational indicator is in when the MOD is operated, let's say you open it or close it and it's rotating, if you need to stop it for any reason, you hit the stop button, it stops it because it kills power to this entire circuit, which de-energizes the open coil or the closed coil. And it's these open and closed coils which send power to the motor. So looking at the circuit, I see multiple paths for open and multiple paths for close. You'll see here, this close button and open button refers to the open and close button located inside the MOD control box that's located in the field. So when I push the open button, this is a logic that sends power to the open coil and opens the MOD. When I hit the close button, this is a logic that sends power to the closed coil, which then enables the MOD to close. There's also a 43 local remote switch, and you remember from a previous video that the 43 is a selector switch. So in the local position, this contact is closed, and my path is this way. Same thing here. In the open, the 43 local remote switch is in local. This is closed. When I place the 43 selector switch into remote, this contact and this contact is closed. Now I can operate the breaker remotely via an output contact. This is the 89 MO relay on breaker on MOD 3B68. What this is an output contact on SEL 2411. So you would send a signal to the 2411 via fiber or Ethernet. The SEL relay will tell output 101 to close, output 101 will close, and now your open path is through this path right here. There's also a test finger in there so you can isolate the remote close. Same thing applies with the remote, this is remote open. The same thing applies with remote close. You have another set of outputs from the SEL 2411 that allows you to remotely close the MOD. So for this particular application, you have remote open and close and local open and close, and that's it. Moving right along down here, you're going to see a note. And you notice this says note 1. There's a jumper there. This OP is the counter for the MOD. So for 48 volt DC application, you will remove the jumper and add a resistor. And it states that right here, 48 volt DC resistor to be installed in series with counter. For 125 volt DC to be installed in series with counter, you just leave the jumper in place. So in this application, we're 125, we're going to leave the jumper. Moving on down here, this is an AC circuit fed from an AC breaker. This circuit also has a 27, which is an undervoltage relay, and it's to alarm the SCADA system that we have power or we don't have power. The circuit also has a circuit breaker, as you can see. There's two of them. One is for the heater circuit. So this is positive, or we call this is 120 volts AC circuit. So this we'll call the hot, the line, and this we'll call the neutral. There's a thermostat there. That's what that TH stands for. And this is your resistor. The note 2 references 240 volt application. You want to place these in series. They're now installed in parallel. Gives you instructions there on how to convert it for 240 volt application. So this circuit is pretty simple. You just have a heater circuit with a thermostat. It turns it on and off. You have a GFI outlet with a ground. GFI stands for ground fault interrupter. You have a light and you have a light switch. You also have a heater circuit switch right here, which is a knife blade. You can turn the heater circuits on and off in addition to the breaker. This is basically a simple MOD 115 kV application, MOD circuit. That's it for this drawing. Have a wonderful day.